So the very things before I will be start, I would like to take a moment to express my deepest gratitude to our esteemed teacher. Your guidance and support through this course have been invaluable. Your passion for the subject matter truly inspired us, and your insight have illuminated our understanding of machine learning and its application. The knowledge and skills we have gained in this course have been instrumental in developing this innovative approach to land cover classification. Thank you for uh, fostering an environment of curiosity learning and growth. Your detection to our education has not only equipped us with tools to tackle this project, but has also prepared us for future endeavors in these exciting fields. Thank you so much, our teacher. So I'm delighted to be here today to share with you our innovative approach to the pressing global issues. Titles of our presentation: Revolution Land Cover Classification with Machine Learning. Land cover land use with machine learning, an innovative approach to protect this land cover land use in our study area in Khartoum city from 2019 and 2050 in Sudan country. Through it, we used Google Earth engine. So in our content, in my presentation here, we talk about small introduction about remote sensing. This science is very important in our project here. After that, what's mean machine learning? What is this? Not a specific definition, but the general definition of machine learning. After that, we'll be to talking about what is the difference between land use and land cover, and after that we'll be to talk about our study area, this project where we'll set up or where we created this project. After that, we will talk about the objectives and methodology of our project. After that, we'll be to talk about the Google Earth Engine classifier, method classifier here. We have a plenty of method. So the last thing will be to talking about the analysis and result of our project. So this first thing will be the small introduction of what is remote sense, understanding the remote sense, because this science is the base of our project. Remote sense is the acquisition of information about an object or phenomena without making physical contact with them. So remote sense to create our data, to create satellite image. This satellite image, sometimes we create it by satellite or plane or drone. So let us to go. What is machine learning? Machine learning, this small definition here. Machine learning is we have data. After that, we training this data and create model this data and serve protection and answer the question. So the data. This is the first step in the machine learning process. Data is the raw information that you will use to training your model. It could be anything from images, text, numbers, like that. The quality and quantity of data directly influence the performance of the model. So the second thing's training. training, once you have your data, so we have the data, the next step is to training your model. Training involves feeding your data to the machine learning algorithm. The algorithm then learning pattern or structure within the data. This process might involve supervised learning. So where the data is labeled with the correct answer, or unsupervised learning where the data is not labeled and the algorithm need to find structure itself. After that, we created the model. The model is a mathematical representation of the real world process, based on the pattern learned from the data. Once the training is complete, what you get is a machine learning model. This model cannot make prediction or decision without being explicitly programmed of perform the task. After that, save prediction. What that means, after that, after the create our model has been trained, so it can make prediction on new unseen data. These predictions are then saved for future use in the analysis. After that, we answer the question. This is the final step where the model is used to answer a specific question. For example, if your model is it's training to recognize image for cast, you can now feed it new image and it will be able to answer to question. Is there a cat in the image, in this image? Pass it on the pattern it learning during the training. Let me to summary uh, the definition of machine learning in our project. So in our project, we need to classification land use land cover in Khartoum. So our data, we need to satellite image. This satellite image sometimes will came a plenty of places like Sentinel satellite, like Landsat, like MODIS. So after that, we need to training this satellite model to training that to take sample this water body, this building here. After that, we create the model. We need to use the classifier method. After that, the answer the question. So in our project, after in 2050, this land cover in Khartoum, how is it? How to be protect. So let us to go here. The very things here. What is the difference between land use, land cover here? So land cover, land use. Definition: the land cover is the physical material at the surface of the earth, like water bodies here, like agricultural, like that. And land use categorization of land based of it is functional economic use by humans. So sometimes this area for industrial, this area for agriculture. That means this is the land use. Reflects physical feature of the land like grass, asphalt, trees, bare ground, water bodies. This land cover. Here, like human activities and decision, including the residential, commercial, agricultural, and industrial uses. Information source, land cover directly observable from the Earth service. So from the Earth service, this land cover. And of land use often require additional data beyond physical appearance, including the economic. Here is the summary. So land cover tells us what is the earth surface, while land use tells us how the land is being used by humans. So let us to go here. This is a study area. Uh, study area. Study area. This shapefile or this boundary of our study area in Sudan country in Africa. Here, Khartoum is the capital city of Sudan. The name is Khartoum. Khartoum is the capital city of Sudan, located the confluence of White Nile and Blue Niles. Here, this is the White Nile here, and this is the Blue Niles. So Khartoum here, this area. White Nile and Blue Nile. The position at intersection of two rivers gives Khartoum a unique geographical significance. The city is administrative, economic, and cultural center of the nation. The Khartoum metropolitan area is a composite of three parts. So Khartoum, here this is the Khartoum, the center here, Khartoum, well, is the Khartoum, and north of Khartoum here, north of Khartoum and Omdurman, north of Khartoum here and Omdurman here. So together, this region make up the largest urban area in Sudan with a diverse population that represented all ethnicities and culture of the country. Khartoum economy is primarily service-based, with the key sector being government administration, retails, construction, food processing, and textiles. Agriculture also plays significant roles in the uh, outskirts of the city, particularly along the Nile, where irrigation allows of the farming. All these area here, this agricultural area. So let us to after that. In terms of climate of Khartoum experience hot desert climate with two distinct seasons, a long very hot dry season and short warm wet season. This climate condition greatly influence that city land use and land cover. So the physical landscape of Khartoum has changed considerably in recent de- uh, decades due to reliable urbanization and development. This makes it interesting case study for examining land use and land cover change. So let us to go. So here's the specific objective of the project. The first thing we need to collect and clean, prepare land use, land cover data for Khartoum from 2019. So here in our project, we collect 2019, 2021, 2023. After that, protection using machine learning to 2015. So after that, we create model. So here to employ machine learning technique to analyze and classify land cover data within Google Earth Engine. We use this portal. It's a free portal. We're coming to talking about this GEE. After that, to predict future land cover land use change for Khartoum to the 2050 using the developed machine learning. We use it uh, neural network neural network. After that, to evaluate the accuracy and if effectiveness to the machine learning model in prediction land use land cover. After that, to present the finding in the comprehensible and accessible manner, providing available insight for urban planning and environmental management in Khartoum. So here this our methodology. The methodology for project, the first thing, data collection and preparation. The first step involves the collection and preparation of land use land cover of Khartoum from 2019, 2021, 2023 and protection 2080. The data will be obtained from the Google Earth Engine platform, and we use it Sentinel satellite image platform and other relevant data source. The data will be cleaned and transformed into the suitable format of the further processing and analysis. The second thing, data analysis and machine learning model development. In this stage, exploratory data analysis will be conducted to understand the structure and pattern in the data. This will be followed by the application of machine learning technique to classify and cover types. Several machine learning models will be training and testing using the land use and cover data. The performance of the model will be evaluated based on their accuracy in classifying different land cover land use type. After that, model training and validation. The selected machine learning model will be training using the available land use land cover data. The model will be then be validated using the subset of the data that was not used during the training phase. This is to ensure that the model is not only accurate with the training data, but can also generalize with to new unseen data. 5. So we need to protection of future protection. I'm so sorry because yeah, I'm recording from our yurt here. So, uh, okay. Uh, After that here, protection of future land cover land use changes. Only the model in training and validate it will be used to protect future land use land cover change in Khartoum up to the 2080. The model's protection will be based on the pattern and relationship it has learned from the training data. Uh, Last thing, after that, result and validation and interpretation our result. So here, let us to talk about the Google Earth Engine. This platform is very important now, and it's this free platform. So will be to put the question why we use it Google Earth Engine. We have a plenty of tools and we have a plenty of program. Why we use it Google Earth Engine? The first thing is scale of data here. Google Earth Engine access to massive global scale data. That means if we need to create land use land cover for all the country like Turkey here, we can create it. We can create it in small times. But if we have used it like software here, ArcMap, AirDAS, Envy, it is limited to data set available to the user. So we need to I can use this software, but it's difficult. We need a plenty of time, a lot of time here. After that, computer power for here, use Google Earth Cloud infrastructure for high-speed analysis. High-speed analysis, but here limited by user personal computer. Cost is free. This is very important here. I think here can be expensive. Sometimes we need to pay it for this software. It's not free. Collaboration and reproducibility, easy sharing for script for collaboration and reproducibility. Here not strayable, easy to sharing for script, here collaboration and reproducibility. Here not as straightforward. Uh, so let us to animation and programming. Here pass it on JavaScript and Python and API. We can use it here. Here scripting capabilities available, but maybe not as conductive to large scale automating. So this is why we use it Google Earth Engine here. So let us to go. This is the data we use it here, or not use it all the data. we have it in Google Earthing. We have all the image for Landsat satellite image, and we have MODIS satellite, and we have the Sentinel. So let us to go for here. This is the method inside the Google Earth engine. This is the method. We have a plenty of method of classifier. We have like uh, CVM, SVM here, support vector machine, we have it, and we have naive here, and we have random forest. So we have a plenty of method in our portal Google Earth Engine. In our project here, try to using support vector machine, but the accuracy is bad. Why is bad? Because the spatial resolution, if our image is not good, and we need to take a plenty of sample. I think the accuracy for support vector machine here 45, like that, 45 or 50, but use it smile knife base. Knife base is good, accuracy. After that will be to talking about the result. So here this slide explain what is method classifier in Google Earth Engine. So here this after that we take it our data satellite image, Sentinel satellite image. We need to collect training data. This satellite explain our sample data here. So we have a sample from water body like this color, blue color, and parents and croplands and urban. Here this user interface inside in our project. So we use it here, smile knife pies, and here validation errors matrix here, and this is the validation over accuracy 89%. This result here. Let us to go. This is the second things here. I think what is this method? We use it sample here, sample region method. Here 96 prediction, 96 did the accuracy. So and here we use it the same what is sample region, but here 29 here we use to 2021 here 2019 here is the protection. So this is the result here. All the result for land use, land cover 2019, 2021, 2023 here. So and after that we calculating the area of water bodies in 2019 and agriculture and bare land and built up, and the same for land use 2021, and the same for 23 here. This is our result. So this result can be used to create our model to prediction how to appear the land use land cover in 2050. So here this over general vision for a result here. So this our water bodies like this here, and this bare lands here, the building like this, and this agricultural area like that. I think here is clear. Here this for agriculture. This is our result. So after that we need to create our model to prediction the model. We use it QGIS. We have free tools, more land use. Okay, this name. So we need to putting land use and cover 2019, 2021, 23, and we need to putting them digital elevation model to topographical. After that, we go to area change to calculate area change here, and here we used artificial neural network training neural network, and here to validation to create the validation. After that, to protection, simulated protection 2050. Here is the result of our model. After that, land use, land cover 2050, and calculating all the parameters, agricultural, bare lands, built up water bodies. Let us to explain our result here. Let to explain our result. So here this model it have a plenty of time. We start our model in 1 o'clock and finish in night in 10 o'clock here. So it I think closes the 1 day. This our result here. So we have the result of 2021 here. We have agriculture, we have water bodies, and we have and after that we calculating to 2050. This is the shape. In the analysis of land use, land cover, date of city of Khartoum, capital of Sudan, significant variation was observed across of different categories over spent 31 years. So starting from 2019 here. 2019, the vast majority land in Khartoum was classified as bare land, 52.6 here, accounting for 52.6 of the total area. Built up areas coming in the second here, built up coming in the second. 37 flowed by agriculture with 9 agriculture here. I think 2000 is too small, 9. The same in 2023, agriculture here is coming up, and 2023 here, and 21 and 21. So we have other analysis here. So this land use, land cover, growth rates in Khartoum. So water bodies like 66.6 water bodies show growth rate of 66.6, indicating an increasing in water body areas over this period. This increase, although not very high in percentage terms, is still significant and increasing in water resource. So agricultural land saw a dramatic growth rate of 4,088.25, suggesting significant expansion of the agriculture and bare lands of the other lands expanding, decaying with the growth rate minus 75. This reduction in bare land indicated that this area might have been covered into the type of land use such as agriculture built up areas. Built up areas also saw decline with the growth rate of 16.92, suggesting decrease in urbanization of built up space in the city. So this all our result here on analysis. I think to here I'm finishing. Thank you so much.